Have you ever felt like you're talking to a goldfish when you're using an AI? You ask it something, it gives you an answer, and then poof, it completely forgets the conversation ever happened. Well, that whole era is quickly coming to an end. See, the next huge leap for AI isn't just about making the models bigger. So, how does an AI go from having the memory of a goldfish to becoming a genius? The secret, it turns out, is all about memory. Let's break it down. To really get why this is such a massive deal, let's just start with a really simple question. What even is an AI agent if it can't remember anything? I mean, what are we actually dealing with when there's just no recall whatsoever? Well, the answer from the people building these things is pretty blunt. Without memory, an agent is just reactive. It's stateless, which is a technical way of saying it has absolutely no idea what happened even 1 second ago. And it's shallow, totally trapped in these one-off, single-turn interactions. You say something, it says something back, and that's it. The end. No context, no learning, no real intelligence to speak of. And this is exactly why memory matters so much. It's the key that unlocks pretty much everything we actually want an AI to do. It's how it keeps track of a conversation, how it manages a complicated task, how it learns from feedback, and how it can give us a truly personalized experience. Without this stuff, an AI is basically a fancy calculator. With it, it starts to become a genuinely capable partner. Okay, so how do we actually build this? Let's start with the most fundamental challenge there is, just remembering the conversation itself. We're talking about going from those clunky single turns to a real flowing dialogue. The very first and simplest tool in the toolbox is what's called buffer memory. The easiest way to think about this is that it's just like our own short-term memory during a chat. It's like the AI's little working notepad, holding on to just the last few messages so it knows what you're talking about right now. But as you can see here, there's a really clear trade-off. On one hand, it's fantastic for keeping a quick chat on a support line going really smoothly. But on the other hand, its memory is, well, super fleeting. Once the conversation is over, or if it just gets too long, that context is just gone, forever. It can't remember what you talked about last week, and it's no good for tracking complex tasks. So to solve that little problem, developers got clever and came up with something called summary memory. The idea is, instead of trying to remember every single word, which is super inefficient, the agent creates a kind of Cliff Notes version of the conversation as it goes. It compresses the whole dialogue down into the key points. It's a much smarter way to hold on to context for a longer period. And here we run into our next trade-off. Summary memory is incredibly efficient. It works great with the AI's limited processing capacity, what developers call token windows, and it really helps it remember the big picture. But the danger is in the details. When you summarize, you always risk losing some subtle context or some nuance, and its effectiveness really just depends on how good the summary model itself is. Okay, so we've gone from remembering a chat to remembering key facts. The next step up is basically giving the agent a library card to, well, pretty much everything. And this is powered by something called vector memory. Now, forget about simple keyword searching. This is semantic search. It lets an agent look for information based on its meaning and its context. It's basically the AI's research superpower. It doesn't just find words that match. It finds ideas that are related. It's a huge difference. So as you can imagine, it's unbelievably powerful for anything that's knowledge-heavy. Think about a research assistant that can instantly find the most relevant passages in thousands of scientific papers. The downside? Well, it takes a lot of computational work up front to translate all of that data into a searchable format. That's what's meant by embedding overhead. And if your question is a little vague, the AI can get confused about the meaning, which leads to something called semantic drift. Okay, now we get to the kind of memory that makes an agent feel like it actually knows you. This is long-term memory, and it's like the agent's persistent scrapbook. It stores key facts about your preferences, your goals, and your past interactions, not just for one session, but over time. And this is where the stakes get really, really high. This kind of memory is what allows for true personalization, like an assistant that remembers your project goals from month to month. But, and this is a huge but, it has to be handled with extreme care to comply with privacy laws like GDPR. Security and trust are absolutely everything here. All right, so far we've covered remembering conversations and remembering facts. But the real magic happens when an agent can start to learn from its own experience. This is how agents go from just knowing things to actually getting smarter over time. First up is episodic memory. You can think of this as the agent's detailed logbook or its diary. It records every single action it took, every decision it made, and what the outcome was. This isn't just about knowing facts. This is about remembering what it has done, which is absolutely critical for being able to review its performance and improve. And that right there brings us to the real game changer, reflection-based memory. This is where an agent doesn't just log its actions, it actively thinks about them. It introspects. It evaluates whether its past actions actually worked, and then it adjusts its strategy for the future. This is the big leap from an AI that just follows instructions to one that can actually learn and form its own strategy. Which brings us to this. For a long time, the approach in AI was just stack more layers. It was a brute force method to try and get better performance, but reflection is different. It's a much more elegant, a more intelligent path to improvement. It's really about working smarter, not just harder. Okay, we have covered a whole lot of different memory types, but the most powerful agents out there, they don't just use one. They combine all of them to build a kind of hybrid brain, where the whole thing is way, way more powerful than the sum of its parts. So you see, the real secret isn't about picking one best memory type. It's about building a really sophisticated architecture where each system plays its own specific role, and they all work together seamlessly. Think about it like this. When you start a chat, buffer memory is handling the immediate back and forth, kind of like your own short-term focus. Then, as you keep talking, summary memory is jotting down the main points so you don't lose the plot. If you ask a really tough question, the agent uses its vector memory to instantly look up the answer in its vast library. And all the while, the episodic logs are recording the entire process so it can actually learn from the interaction later. It's like a symphony of systems all playing in harmony. And this isn't just theory, Developers are using real tools to build these systems today. LangSmith is used like a flight recorder for logging and tracing everything. The famous OtterGPT project was what really showed the world the power of reflection. And now, there are entire platforms like Letta and Crew AI that are designed specifically to help build these complex, stateful agents. So, to sum it all up, memory is the absolute essential ingredient that is transforming AI. It's the bridge that's taking us from those simple, forgetful chatbots to truly intelligent agents that can have coherent conversations, access huge amounts of knowledge, and, most importantly, learn and adapt over time. Which, of course, leaves us with one final, pretty fascinating question to think about. If an AI has a perfect memory and the ability to learn from all of its mistakes, and the capacity to continuously self-improve, what are the limits? What can't it eventually do? That's the future we're building right now, one memory block at a time.